Hi, welcome to Imperium Learning. In this video I'm going to be showing you how to estimate an Arch 1 model in particular. I should just say you'll normally be estimating an Arch model if you've already estimated an armor model and you've found that it's the residuals of your armor model exhibit arch effects. So that's the first thing that you should bear in mind. Don't estimate this until you've already done some residual testing on your armor model and you found that it does exhibit arch effects. So when you look at the returns on a chosen financial asset or maybe an index fund of some sort, you might find that the returns of the asset are not constant. And particularly when you look at the returns of an asset over a long period of time, let's say just at least 5 years. And so it would be useful in that scenario to be using an arch model rather than something else, like say a least squares model or something like that. So I've got my own example, which is based on my own data set here. Just get rid of that. Just right click, open, view, graph. Okay. And as you can see, just like the picture that I have in my PowerPoint, you can see that the returns, that the variance is not constant. So even though we've kind of got a zero mean going across, we can see that at different time periods that the returns are in some cases drastically different. And I suppose your eyes will immediately be drawn to these massive fluctuations here, which probably coincide with the Brexit vote in the middle of 2016. And so because we've seen that the returns are not constant over time, the variance of the returns are not constant over time, it means we're going to have to try to use a model which allows for this to happen. Now bear in mind as well, I just want to draw your attention to something else, which is that you'll notice that the variance will be sort of stable. It won't fluctuate too much for even prolonged periods of time, and then all of a sudden when some kind of shock happens, you'll notice that the variance will massively go up, and then you'll have a sustained period of increased volatility in your returns. Right? Now that's really important to bear in mind, because this leads on quite nicely onto some concepts that I want to make sure that you're aware of as we go forward. And the first is something called volatility clustering. Now, just to briefly summarize what that is, all it means is that large returns will follow large returns and small returns will follow small returns. And that means if the volatility of the returns of an asset are high in a previous period, they're probably going to be high in the current period and may even still be high in future periods. Whereas if the volatility is very low and stable, well, that means it's probably going to be low in the present and future periods too, until a shock is introduced. And also something as well, which is the leverage effect. Volatility tends to increase more following a large price fall rather than a large price rise of the same magnitude. So in other words, when things are going badly for a financial asset, that means that it becomes a lot more risky, it becomes a lot more volatile, and it becomes a lot more risky. And because it's a lot more risky, the volatility of its returns increase. So these are two important concepts that you should be aware of as of right now, as we progress forward: volatility clustering and the leverage effect. And so now we're just moving on to the main part of the video, which is, and don't worry by the way, I'm going to show you how to estimate one of these models very quickly in the next few minutes. But as you can see here, what does an arch model consist of? It consists of a conditional mean equation and a conditional variance equation. And bear in mind, only start estimating arch and Garch models for the returns of an asset. Don't estimate, so just to go on Eviews very quickly, I've got my Lund pro, okay, well basically, I've got my price, and this just shows the close price for my chosen index fund at the end of each day. As you can see, it's very high, judging by the values on the y-axis. Then all you have to do is convert it into logarithmic form, like I've done, like that. And as you can see from the values on the y-axis, they're a lot smaller now because they've been converted into logarithmic form. But when you're doing estimating arch and Garch models, you're going to want to have the returns of an asset. Now, how do you calculate the returns of an asset? All you have to do is difference the logarithmic form of the price data of your chosen asset. So when we look at returns, this is all it is. It's just the first difference of Lund price. Okay, that's all it is. So just very quickly, moving on then, how do you calculate your conditional mean equation? Your conditional mean equation will be the ARMA model that you estimated in the previous step. And in my case, in my chosen example, that would be an ARMA 4-2 model. And that's how you'd write it down, by the way, just in case people don't know. And just pay very close attention to that term right there. Notice how there's a t besides sigma squared. That allows for heteroscedasticity as opposed to homoscedasticity, depending on the time period. So just bear that in mind. That's how you would write it down in word form. Now bear in mind that the conditional variance equation for an arch 1 model would just be a constant. So this is a constant here, alpha 0, plus the previous value of the squared error. So in other words, the value of the squared error in the previous time period. Bear in mind that if we had an arch 2 model, we'd have an additional term there that would say alpha 2 u squared t minus 2. Okay, and if we had like an arch 3 model, it would be alpha 0 plus alpha 1 u squared t minus 1 plus alpha 2 u squared t minus 2 plus alpha 3 u squared t minus 3. So just bear in mind that the number in brackets is the number of lags of the squared error that you're going to have for your conditional variance. Just realized in another slide I've got examples here just to emphasize what I mean. So this is the conditional variance for an arch 2 model, and that right there is the conditional variance for an arch 4 model. All you have to bear in mind is that the number in brackets refers to the number of lags of the squared error. So that's all we're gonna bear in mind. Fortunately, I've already sort of approaching the 10-minute mark, so you're gonna have to see another video which I'll be doing just now, which shows how we actually estimate an arch model. Okay, so I'll wrap it up here. Bye.